Hello everyone, welcome to Applied Engineering. Today's video is all about refrigerants in heating, ventilation, air conditioning and refrigeration, their past, present and future. We will compare some of their thermophysical properties and their GWP, that is global warming potential, and ASHRAE safety groups, and bring it to life with some cool comparison. Whether you are an HVAC pro or just curious, stick around, this video is going to be very informative for you. So let's get started. First, we will shortly discuss why do refrigerants matter in HVAC. Then we will move towards the refrigerants timeline. After that, I will define key comparison criteria for their selection. And then according to that defined criteria, we will compare these refrigerants and their properties. An interesting thing in it is that we will also run a small simulation in a semi-theoretical vapor compression cycle simulator called Cycle DHX at the end to check the performance of these refrigerants so that we can do a justified comparison among these refrigerants. So why do refrigerants matter in HV and AC? So refrigerants are the heart of a cooling system. They absorb and release heat to keep us comfortable. They are the core working fluid, and refrigerant is the medium that absorbs heat in the evaporator and rejects it in the condenser. Their selection is actually a balancing act between the performance versus environment and flammability. This figure shows different refrigerants which are used in HV and AC, and you can see their ODP values along with their GWP values and the safety classification. The refrigerant selection affects different criteria and parameters. For example, energy efficiency. Different refrigerants have different thermodynamic properties, enthalpy change, pressure levels, which directly affect the COP and system performance. Number two is the environmental impact. Refrigerant choice affects ozone depletion potential (ODP) and global warming potential (GWP). Number three, safety consideration. Refrigerants vary in flammability, toxicity, and operating pressures, influencing design and regulations. Number four, system dynamics. Changing the refrigerant alters compressor work, mass flow rate, and heat exchanger sizing. Number 5. Configuration changes. Switching refrigerants may require redesigning components like compressor displacement, expansion devices, tubing size. The future trends regarding refrigerant selection is that the industry is nowadays is shifting towards low GWP eco-friendly refrigerants. Following is the refrigerant timeline. In the past, we were using R22 and R134A, which were widely used in older HVAC and refrigeration systems. They have good efficiency but high ODP and GWP values, leading to environmental concerns. Gradually, these refrigerants were phased out under the Montreal Protocol and environmental regulations. Presently, we are using R410A, R32 and R152A. These are the current mainstream refrigerants with zero ODP and relatively better performance. R410A is common in air conditioners but still has high GWP value. R32 and R152A have lower GWP values, better efficiency but with mild flammability challenges. They represent a transition phase balancing efficiency, safety, and environment. In the future, we are having some very low GWP, excellent efficiency alternatives. For example, R290, which is propane, has excellent efficiency, very low GWP, but highly flammable. R1234YF has ultra low GWP values, already replacing R134A in vehicles. R454B designated as a direct replacement for R410A with lower GWP values. Let's set the stage with our comparison criteria. So, boiling point determines how easily the refrigerant evaporates in the evaporator. It defines the lower refrigeration temperature limit for a refrigerant. Critical pressure, the maximum pressure above which refrigerant cannot exist as liquid. It impacts compressor design, efficiency, and system safety. So the boiling point defines the lower refrigeration temperature, whereas the critical pressure defines the highest condenser pressure. These are the major two parameters for the selecting criteria of any refrigerants. Global warming potential shows the refrigerant contribution to climate change compared to CO2. Lower GWP means more eco-friendly. ASHRAE Safety Group classifies refrigerant by toxicity and flammability. A1 means safest and non-toxic and non-flammable, whereas A3 represents highly flammable. And then finally, the coefficient of performance, a measure of energy efficiency. Higher COP means more cooling for less power, and it is crucial for cost and sustainability. These parameters together let us judge the refrigerants not just on performance but also on the environmental and safety impact. So, this table represents the comparison between refrigerant properties. The refrigerants are arranged according to the era or the timeline. First come the refrigerants of past and present, which are R22, R134A. Then comes the refrigerants which are presently used, which are R410A, R152A, and R32. And then comes the future refrigerants, which are R290, that is propane, R1234YF, that is tetrafluoropropene, hydrofluoroolefin, and R454B. Here we can see their boiling points in degrees Celsius. We can clearly see that our 134A and 152A has the highest boiling point values, whereas R32 has the lowest boiling point of minus 51.7 degrees Celsius. Here we can see the critical pressures, and we can clearly see that our 134A has the lowest critical pressure of 4.06, whereas our 32 has the highest critical pressure of 5.77 megapascal. Here we can compare the GWP values of these refrigerants, and we can clearly see, like, as we are moving from past to present and then to the future, the GWP values are decreasing. Here we can see the safety group of these refrigerants. In the past, we can see mostly we were using A1 category refrigerants which were non-flammable. As moving along, we can see that the flammability is getting increased and it is shifting towards from A1 to A3 and A to L. A3, which is the highly flammable refrigerants, and A2L, which is a recent category introduced by the ASHRAE group, represents less flammable refrigerants. And A2L category comes between A1 and A2 category. So A2L category refrigerants are actually lower flammable as compared to A2 category refrigerants. In the remarks column, we can see that the R22 is already phased out due to its ozone depletion potential. R134A is used in chillers and cars. R410A, which is presently used, has high GWP value of 2088, and R152A has low GWP value and it is usually used in portable air conditioners. R32 has high efficiency and it is replacing R410A, but it is a little bit flammable. R290 is a natural refrigerant and is very efficient, but again it is highly flammable and comes in A3 category. R1234YF, which is a hydrofluoroolefin, is recommended for used in automotive air conditioning and it is a low pressure refrigerant. R454B is also designed to replace R410A. To evaluate the COP of single-stage vapor compression cycle, a semi-theoretical simulation software, Cycle DHX, is used. All refrigerants were analyzed based on fixed condition to get a fair comparison. The fixed condition includes fixed cooling load of 7 kW, which is almost a 2-ton air conditioner, fixed heat transfer fluid or air temperature at condenser and evaporator, and fixed configuration of evaporator and condenser. The cycle DHX provides the detailed results, but only the COP of cooling is discussed in this video. For the detailed comparison of these refrigerants using cycle DHX and how to do that comparison using cycle DHX software, please see my other video in which I have explained in detail the comparison and how to use that software. So in this slide, we can see that after running a single stage simulation in cycle DHX, we have also obtained the COP values of these refrigerants along with their GWP and safety group values. So now I will compare and I will give a final verdict based upon the GWP values, the safety group and the COP. So here we can see for the R22, it is already phased out due to its ODP value. Then comes R134A. R134A is non-flammable, has high GWP value but a moderate or good COP value. Then we can see R410A, which is presently used in the air conditioning and HVAC systems, and we can take it as a baseline. It is also non-flammable and it has the lowest COP value of 7.840. It has high GWP and we can say moderate COP values as compared to others. And then comes R152A. R152A is a bit flammable, comes into A2 category of ASHRAE, but it has the excellent COP value. Here we can see its COP value is highest among all the refrigerants in the comparison. Then comes R32. R32 is a flammable and has a moderate COP values. After that there is R290, which is propane. It has a good COP values. It's a natural refrigerant, very efficient, but it is highly flammable. Then we can see R1234YF. It is less flammable and has a good COP values. And at last comes R454B, which is less flammable but it has a moderate COP value. Based on these previous results, we can come up with a conclusion. And the conclusion is that there is no perfect refrigerant which has all the desirable properties. And there is always a trade-off which is involved between the GWP values, the ASHRAE safety group, and the COP of the refrigerant cycle. The future favors low GWP or ultra low GWP refrigerants with mildly flammable category of A2L. R152A, R1234YF and R290 are the leading replacements in the future HV and AC industry. Their COP value is comparable, but safety and regulation also matters a lot because they are not inflammable refrigerants. So based on the application, the safety level and the environment, you can select your refrigerants accordingly. Like, share and subscribe my channel if you like more videos and updates. That is the only way of supporting and motivating me. Thank you very much.